given the graph, here's 3, it comes down to 2 at 1, and then at 1 you have negative 1, and you start with a smooth graph. So that the value here is. This is actually a place where you have a horizontal tangent, but then goes up again. Now, question 1. When is f prime less than 0? Okay, f prime is less than 0. That means the function is decreasing. So it must be between 0 to 1. So in this interval, 0 to 1, the function is decreasing. Second question is, when is f double prime positive? Now, let's draw this picture to help us. So being positive means it should be curved this way, so you have to think of something pushing from above. And let me ask this, if you have a straight line, what's the value of f double prime on a straight line? It's equal to 0 because there's no concavity. It doesn't concave, it's not concave up or down. So if you have a straight line, it's equal to 0. Therefore, since we're looking for something that's strictly bigger than 0, these portions where it's a straight line is it's not part of the answer, and you have to look for places here. And over here, it looks like something is pushing from below. Over here, it looks like something is pushing from above. So this part should be the answer. So 3 to infinity, or 3 to infinity. Assuming that they extend the same manner. Or you can just say that they end at 5 or something and write 3 to 5. It doesn't matter. Now, what if the question was f double prime equal to 0 or bigger? How would you answer that?
Negative infinity to 0.
Then negative infinity to 0 should be included, and 0 to 1 will be included, and 3 to infinity will be included. So all these should be unioned. You have to union all these 3 intervals. So negative infinity to 0, which is here. I can't talk about the derivative at 0 because is this differentiable at 0? The answer is no, because it has a sharp turn. You don't have a well-defined f prime here, therefore you can't think about the second derivative there. So that's why you have to leave out the 0. But negative infinity to 0 is a straight line, so the second derivative is 0. 0 to 1, it's a straight line, the second derivative is 0. 3 to infinity, it's concave up, the second derivative is positive. Okay, so this would have been the answer if there was this equal sign in there. Okay. Okay. Now, do we see an inflection point?
Yes.
The answer is yes. Where? At 3, 2. At this point. Before this point, it's concave down. After this point, it's concave up. Question 4. It's asking, find all critical numbers. So what's a critical number again? These are the places where the derivative is 0 or not differentiable. Okay, so first, tell me the points where the function is not differentiable. At where?
at 3, x equals 0,
x equal to 0 and
and x equals 3. Well, wait.
now x equal to 1 is another point where it's not differentiable. When the function is not continuous, any point that the function is not continuous, it's not differentiable. So at 0 and 1, f prime doesn't exist. And in addition to this, there's a point in this graph where the derivative is equal to 0. What's that point? For what value of x is the derivative equal to 0? 3. So at 3, it's a horizontal line. So those are the critical numbers. Does the function have any relative maxima? If it does, write the coordinates. Okay. Relative maxima. Okay, so relative maxima can only happen at critical numbers. So we only have to inspect the critical numbers. So let's first think about this point. If you look at the left and right of this point, is it lower than this point 3? Yes. So 3 comma 0 is 0 comma 3 is a relative maximum for sure. Now if you go to 1, here's the value at 1, the value is 2, but if you go left, there are places where it's more than 2, right? And although if you go right, there everything is less than 2. So that means that before 1, since it's bigger, this cannot be a relative maximum. So this is not a relative maximum. So 1 comma 2 is not a relative maximum, so we can't write here. And 3 comma 2, that's not a relative maximum because if you go right, it goes up. So there are places on the right that's above this point. So the only relative maximum is 0 comma 3. Okay, now the last question is, does this have any relative minimum? Again, you have to look for the critical numbers. And since this is a relative maximum, that's out of the question. Here, if you go to the left, everything is above this point. But if you go to the right, things are below. So this cannot be a relative minimum. This one also, although if you go left, there are things that, although if you go to the right, there are things above it. If you go left, there are things below it. So this cannot be a relative minimum. The relative minimum means locally it has to be the lowest point. But if you put a small neighborhood, you can see that to the right of it, it's slightly bigger than this point, higher than this point. To the left of it, the left side is slightly lower than this point, so it cannot be a relative minimum. Now, when you have a jump discontinuity, the place of this closed circle and open circle does matter, because if the graph was like this at 1, then this point would be a relative minimum because the value at 1 is this point, and if you go right, it's above this value. It's higher than this value. If you go left, again, everything on the left of it is higher than this point. So if you just look at slightly before and after 1, if the circle was, the closed circle was here instead of there, then this point would have been the relative minimum. Okay? So that's something to think about. Any questions?